Okay, so let's just talk about all those definitions that we have to know what we're talking about. Now, we first have what's called the rotation angle. Now, just so you know, everything in trig starts at 3 o'clock. Okay, so we're always going to start at 3 o'clock. The other thing that starts at 12 o'clock is your bearing, right? Like if you were using a compass. So 22 degrees would be from north if that was from bearing. But everything else comes from 3 o'clock. So every time we do an angle, it is going to be at 0 degrees is 3 o'clock. And then we are going to go counterclockwise for positive. Okay, so if you come down here, you can see we have the positive angle, and that's when you go CCW. That's counterclockwise. If you ever see CCW in the book, it's used quite a bit by the author. That just means counterclockwise. Okay, and that is in a positive rotation. Now, the negative angle or negative rotation is clockwise. Okay. The next thing you need to remember is your quadrant numbers. Now, quadrant 1, this does not seem intuitive, does it? Okay? But it's not like somebody just got 4 quadrants and said, let's name that one quadrant 1. Okay? If you think back to all the graphing you did in junior high and in elementary or whatever, you were always in here. Right? If you were like, you know, the amount of water that a plant needs, the amount of water was, you know, and then the height, or amount of water was on the bottom, and then height would be whatever. You never worked in the other ones. Okay? Whereas when you maybe started to get in higher levels, you started maybe going down to or over here or over here. Very rarely is a graph in this area. Okay? Like one you would use in research and stuff. Now, so just always remember that is quadrant 1, this is 2, this is 3, and this is 4. Now quadrants are usually given in Roman numerals, but when I do them, I'll just go 1, 2, 3, 4, like I just do the numbers, right? So again, I'm just doing this as review so you guys remember. So where would 290 go? Which quadrant? Quadrant 4, about there, right? And how do you draw it? You just draw it like that. Okay, now 750, how would we draw 750? And where would it end up? Okay, so 750 goes around once, obviously, 360. And then around again would be how much? 720. And then there would be about 30 more. So how do you draw an angle like that? Well, I'm glad you asked. Because you go like this, and then like this, and then like that. And again, I'm a trained professional, so do not get upset if yours doesn't look as good as mine. It took me years to get to this point. Okay? Like if I look at Kelsey's, I mean, yeah, a little bit more work. And that's okay, right? And so it makes you human. Okay. Let's talk about coterminal angles. Anyone remember what coterminal angles are? Yes? No? Don't ask me. Coterminal. Now, first of all, terminal is not a very nice word. Okay, you never want a sentence with terminal in it when someone describes you or anyone you know. Okay? No, I don't. Okay, so terminal means to stop. They co-stop. They all stop in the same place. Now, if we were to do 150, 150 is like here. If we were to do negative 210, surprise, surprise, it ends here. So these would be called coterminal angles. But only one of them is the principal angle, and that is this one, because the principal angle is the smallest positive rotation between 0 and 360. Now, whenever you describe all the coterminal angles, it must always be principal angle plus 360n. So if they give me negative 210, I would not say that all of the angles are negative 210 plus 360n, because that's not the principal angle. So how would I describe every single coterminal angle to this? I get the principal, which is 150. And how would I come back to that is 360 n. Now n has to be like 1, 2, 3. I can also go negative 1, negative 2. So n is in the integers. Okay? To turn 360 degrees puts you right back where you started. Okay? Like, I think I even told you this last year, but I was like watching the news and this guy was like talking about how he had, he lived this life of crime and stuff like that. And he says, you know what? I've taken a whole 360 degree turn in my life and I'm back on track. Now I'm living a good life. And I'm just, well, 360. I think he meant 180. But I'm not here to judge. Okay? If you take a 360 degree turn in your life, you have done absolutely nothing. Okay? Now, let's go to reference angles. Again, this is all review, and as you're doing the work, using your solution manual, it'll make sure that you are doing this stuff, right? Now, remember reference angles. We do everything with reference angles. Josh, please put that away. Okay? Now, reference angles help us determine all the answers. Your calculator is very limited in helping you with this trig. If you put, sine, or second sine 1/2, it'll give you just one angle. But there's actually two angles that sine theta can equal to give you the answer half. Okay? But your calculator will only give you one. We need reference angles to be able to find both, or sometimes four answers. Okay? You can have 0, 1, 2, 3, or 4 answers for a question. Your calculator will only give you one ever. Okay? So you can see that one will not be on the diploma. They do not want anyone accidentally getting the answer. Okay? Every diploma I have ever seen, I don't know any of the questions you could accidentally get. Okay? They make sure that those don't show up on there, because they want people that actually have the knowledge to be getting those right. So your reference angle, and again, this is a very, very complicated definition, but it is the acute angle formed between the terminal arm of the rotation angle and the x-axis. Okay? Most of you, that meant absolutely nothing when I just said that to you right now. Now, if you break it down, it'll always be the angle to the x-axis. Always. And it's got to be less than 90. Okay? So this is our, what we call reference angle. This would be a reference angle of 60 degrees. So this is my reference angle. And the rotation angle would be 120 degrees. Okay, now if you remember from last year, remember we did reference angles last year, rotation angles, all those. If you come down here, remember that my reference angle equals rotation angle. How do I find this rotation angle? Well, this is 180 minus the reference to give me my rotation angle. So 180 minus the reference gives me my rotation. This stuff is the biggest waste of time to memorize. It should make sense when we go through them. So when I do these, when I teach these, I draw a picture every time. Okay? I'm a very, very visual person. If you show me, you know, where the directions on a map, I got it. Okay, if you just tell me them, like I glaze over in about 1.3 seconds and I get none of it, right? I just wait till you're done and then I go like, can I Google Map that? And they go, yeah. And I go, okay. Okay. And if they say no, you can't because it's not on Google Maps yet because it's so new. Then I'm like, okay, well we better draw something because I have no idea what you're talking about. Okay. But Google Map will find it. Okay. That's a nice thing about Google Maps. They like keep refreshing that. Like my GPS and my vehicle, like half the city is so new that I mean, I'm in a field every time. Field with a little tree in it. I'm driving on the tree. That's how good that GPS is for me. Now, let's just state the reference angle. We'll just do one of them so you understand. Now, they give me the rotation angle is 195. So we got to think 0, 90, 180. So 195 is over here. Okay? So out of common sense, not memorizing, but how could I find this angle if I knew that this was 195? So 195 minus 180. Again, if you draw a picture, I think it does make more sense than if you go and just memorize. And I go, okay, guys, come on, that's a quadrant 3. So remember what the rule was? Take 180 plus reference and do this, right? Again, most people do. They glaze over. But if I just draw a picture and they go, oh, yeah, okay, I get it. If I take 195 and then minus 180, I should get that little chunk, okay? Now, the next question, this is a very common question because you're not going to accidentally get this one, okay? It says determine all the 4 angles that have the same reference as negative 128. Okay, this is a very hard question to do or very easy question to do if you know the language. Now, first of all, figure out where negative 128 is. So you do have to have the knowledge of even what a negative angle is. It's still going to start at 3 o'clock, but 128 would end up somewhere around here, right? There's my 128. That's a negative, but remember, it's not like a negative angle. It's a negative direction with that angle. Now, by using common sense, could you find that reference angle there? What would it be? How would you find this? Because that's what we first got to find. You'd go 180 minus 128. Now, there's no real formula. Doesn't that make sense? Like, that's 180. That's 128. I should get that little chunk from there. So, again, that's where drawing the picture kind of comes in handy. What do we get? 52 degrees. This is my reference angle. Now, I'm supposed to find all the angles between 0 and 360 that have that reference angle. So all I do is, with a new picture, whatever, I've got 52, 52, 52, and 52. It's asking me these 4 angles. And without even looking at the last page, could we find all the rotation angles? Now, in quadrant 1, what would the rotation angle be? 52 degrees. And if you go look over there, there's a formula, rotation equals reference. Okay? How would you find the next one? 180 minus 52. Because we did this one. Now we're doing this one. Okay, we're doing the rotation angles, and you get 128 degrees. How would you find the next one? 180 plus 52. Does that make sense? So that's my next one. 180 plus 52 degrees. And that is 232. Okay, and how would you find the very last one? 360 minus 52. and you get 308. Okay? Okay, and they may just say, add all the degrees up and write it in box number 4. Okay? Now, it is one of those really impossible questions to fluke off. I mean, some of you might say, well, I know how to do it, and I might make a mistake. Okay? So, this one you could do, I would do it once, I'd come back, I would do it again. And remember when, just a little tip of checking things, something like this does not take long to do it again. If you check it, you probably will not find the mistake. If you do it again, and you're like, okay, well, I don't see the answer as last time. Now one of them's wrong. So you look through the two sides, and maybe you screwed up when you did it the second time. Maybe, doing it again is a really good way to check things over. Okay? I get this almost like sick feeling in my stomach when the students pop down their book and go, I made a mistake. Can you help me find it? And I'm like, ugh. Okay. So they got like half a page of stuff, and I'm supposed to find out where 1 + 1 = 3. They did that somewhere, and I got to find it. It's hard. Okay? If I had the exact one beside me, I could find it maybe faster, but it is a time-consuming thing to find mistakes. So we're doing 1 to 7, A, C, E, and 8 to 12. Okay. Okay, so today now we're going to venture into new territory. Now the unit circle that you used last year, all we did was use the degrees on it. Now we're going to move into radians. Now, what some of you are going to want to do is try to hang on to degrees as much as you can and try to convert everything to radians at the end. And if I was sitting in this class, that's what I would probably do. Okay? It'd be the worst thing to do, but I'm kind of stubborn that way. I'm like, hey, I can do it all in degrees. I'm good with degrees. Degrees make sense to me. I can picture it. You say 36 degrees. I know where that is. You say 3 pi over 2 radians. I have no idea. I'll convert it to degrees. Now I know where it is. Okay? So if that's the way you're thinking, I totally get it. And if you want to hang on to degrees for as long as possible, I totally get it. But you, like I was, will get frustrated and more frustrated and more frustrated as it gets more difficult, because those people that learned it in radians and actually understand what a radian looks like, they're really getting this stuff and they're understanding it. And they're not having to do that conversion and then come back and do the question. Okay? So, if you want to stick with degrees, I get it, but I promise you, you will hate it in the end. Okay? You will regret it. Today, you're going to say, I got by. I can do this. I can just always think in degrees. Okay? What I need you to do is do a new way of thinking. It is more specific, and it's actually easier and faster. It is no fluke that your calculator defaults to radians every time you clear your calculator, because it is the preferred way when doing calculations. And you'll see why as we go through this. Now, the first thing I want to show you is what a radian looks like. Now, a radian is an angle, okay? And an angle that is very, very specific to what you're going to see right here. Now, let's just throw any radius out and say that's 3 centimeters, okay? Now, a radian is actually when the radius is the same as the arc length. Now, an arc length is this right here. So this is 3 centimeters, and obviously this would be 3 centimeters as well. Now this here is the angle 1 radian, 1 rad. And it is approximately, now when you say approximately, you put an equal sign with just a little worm on top. And that's approximately 60 degrees. It's like 59.6 or something like that. It's not quite 60 degrees, but it's very close. So here I'm already trying to make, I'm keeping you there, right? I'm going to give you a sort of something to learn, to maybe get a visual. But that's what a radian is. It's actually a piece of pizza. Okay? That's what a radian is. So if you didn't know about degrees, it might be actually better to learn radians. Because you kind of have to, some of you guys are going, okay, 60 degrees, got it. I don't know what a radian is, but I get 60 degrees, so move on. Now, in your estimation, how many radians would you say are in half a circle? Just look up there. How many radians would be in half a circle? How many of those do you think would be to get me over right here? 3. It's approximately 3. To be more specific, it is 3.141592 radians make up half a circle. Okay? So how many radians are in half a circle? Pi radians. Now, this right here, to you right now, that's like, oh my God, pi radians. Okay? Now that may look pretty complicated, but that means 3.141592 pieces of pizza. That's what that means. Okay? So pi is not a variable. Pi is an exact number that angle is. I'll tell you, NASA does not use degrees. Okay? If they're sending something to the moon, they're using radians, because it goes to a couple hundred decimal places, well, a few gazillion, but if they have it to a couple hundred decimal places, they're feeling pretty good they got the right orbit or trajectory, right? Now, how many radians do you think are in a circle? 6 or 2 pi. Okay? So, let's do this too. There's actually, almost, okay, that would be pi radians if I was to go all the way around. Okay? There would actually be 2 pi radians, or approximately 6 radians. Okay? You will know that when you've used radians long enough, you hear the word rad, and it's not even funny anymore. Yes, it was. That's because you're a bitter, cynical old man. The rest of us think it's pretty cool. If you hang around any skateboard park, you're going to hear that when he lands that jump. It's pretty rad, man. You're going to be thinking, oh, crap. I got all that trig homework to do. I better go. Okay. And then I know I have one. I've broken you down. Okay, so do we know what a radian is? And do we know there's a little bit more than 6 of them in a circle? There's actually 6.28 of them, or 2 pi of them. Okay? Now, we have to understand that 2 pi radians is equal to 360 degrees. Okay? Does that make sense? Now, I can simplify this a bit because I can divide both sides by 2. So I get pi radians equals 180 degrees. So if I want radians, I could just turn to the next page and go down to the very, very bottom. Pi radians is 180 degrees. We just showed that. Well, if I want to take degrees and turn them into radians, I will multiply by pi over 180. When I take radians and multiply by, if I have radians and I want to make them to degrees, I'll multiply by 180 over pi. Now again, you're thinking, oh crap, 2 more formulas to memorize. Okay? Well, all you have to know is that there's a 180 and a pi in the formula. Which one is on top? I'll show you very easily how to do that one without memorizing it. Okay? So you got 180 over pi or pi over 180. It's one of those if I got to convert. Okay? How do I do that without memorizing which one goes on top? Because that's a crappy day when you mix that one up. And 4 questions go with it. Now, all of you guys took Science 10, and some of you guys have stuck into physics. But one of the most valuable thing you learn, I believe, in Science 10, in the physics, and in physics in general, is learn how to cancel units. Okay? Many formulas have been made just by canceling units. And if you know how to cancel units, you can derive so many formulas, you will cut your memorization down probably to 90% of what they give you all these formulas, but you can just derive them if you know how to cancel. Okay? Now, if you see, I've got to convert from degrees to radians. Now, most of us have turned the page so fast we actually don't know the formulas honestly right now. So I have 2 choices. I could go 180, don't write this down, just watch. I could go 180 over pi or pi over 180. I got a 50-50 chance of getting this right. But I got to turn this into radians, correct? What should be gone? The degree sign. Only one of these helps me cancel the degree sign. The first one or the second one? Second one. So this makes sense because here there's a degree in the top, degree in the bottom. Okay? So now I don't have to memorize anymore. Just make sure I don't go 180 over, because then I would get like degree squared. And we're not doing any degree squared this year, so you don't have to know that one, okay? So the 270 over 180, we're actually going to be in terms of pi. 270 over 180, you just put that into your calculator, leave the pi there, and all you have to do is go math, enter, enter, and it will reduce the formula for you, or you could just divide by 90 on both, and you will get 3 pi over 2 radians. So what if it says convert to the nearest tenth? Well, that, you would still go pi over 180, but then that one you would go 70 times pi and use your pi button. Don't use 3.14. 70 times pi divided by 180. And it said to the nearest tenth, so how many radians is that? Huh? I'm not getting 1.7. What do I get? 1.2. Now, remember what 1 radian looks like. It's just a little bit more. 1.2. 1 radian is pretty close to 60. 1.2. Well, that makes sense, right? That's just a little bit more than 60. So 1.2 radians. Now, you can put 1.2 or just 1.2 radians. When I ask you an angle and you put 70, that means 70 radians. Why? because there's no units. So you have to know if you put the degree sign, obviously that's what it is. If you put nothing, it doesn't mean degrees anymore. Okay? So radians is so much more commonly used that it doesn't even need to be there. You can just put angle equals 1.2. And you're like, 1.2, what's that? 1.2 radians. Okay, what's a radian? Well, radian's 60 degrees, so it's a little bit more than that. Okay? Now let's just try one the other way. How would I do pi over 4? Now again, you have two options. But what would we like to cancel? Pi. So if you did this, not canceling, I get pi squared, right, on top. So you do not have to get down to memorizing as long as you do some thinking, okay? Those will cancel. 180 over 4 is 45 degrees. And pi over 4 is 45 degrees. Okay. Now, remember how we were doing all the, we'll just come right down, right down to this chart. Reference angle, that was the same with the rotation angle. We were doing the 4 quadrants, remember? We were doing these. Okay. In the second one, how do you do it? It's 180 minus reference. But when we talk in the terms of radians, we'll just turn these all to pi, okay, and 2 pi. So how would I find the reference angle in radians? Well, I'd go pi minus reference. For quadrant 3, I would go pi radians plus reference. For the last one, I would go 2 pi radians minus reference. Okay. No, you're not going to change it to decimal. Unless it's a numerical response and it wants it. No, it will be negative. Okay. Let's now 3 pi over 4 right now probably seems quite obscure to you guys. Okay? But I'm just going to give you a quick way that I know where every one of them is on the unit circle. This is my patented way of memorizing the unit circle. Okay? The first thing I do, because your goal, you're in the gym, you're sitting there, you got your little sticky things on, you've like done your signing, Miss Kroll prays, and then says, okay, open your book. As soon as you open that book, it's unit circle. Get it down, and then question 1 will not be a trig question, guaranteed. But I would still get my unit circle down first, and then you should be able to get that thing done in under a minute. Okay? It's a good investment, because then you're just like, okay, done. And I would, there's a tear out piece of paper, I'd get it on that, because you don't want to keep flipping and flipping back, right? You want to have it out, and you want to do your unit circle. Now, this is how I have memorized unit circle. Now, whenever I see anything over 4 or 2, I know exactly where it is. Now, this is how I just want you to watch, okay? Starting at 3 o'clock all the time. This is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay? So when you ask me, where's 3 pi over 4? 1, 2, 3. I know exactly where it is. Where you ask me, where's 7 pi over 4? 1, 2, 3, 4. 7. I know exactly where you are. Okay? Now, is there a 6 pi over 4 on your unit circle? It's 3 pi over 2. Why did they do that? They just reduced the fraction. So if I see 3 pi, if you said 3 pi over 2, I'd make it over 4 in a second. Okay, that's 6 pi over 4. 6. Okay, I know exactly where you are. So whenever it's over 2, see, the first one, it's pi over 4, then it's pi over 2. That's 2 pi over 4. So 1, 2. I know exactly where you are. Okay? So that's how I find myself in the unit circle. If it's over 2, make it over 4, and then count. And like I don't want to brag, but I'm so good at counting by ones. So I know it's a little obvious, but that's how I use it. Okay? Count by ones, put them over 4 every time, and then reduce the fractions. Maybe you're not good by ones, okay? But something you should probably work on. So that's how I do those. Then the other parts of my unit circle, and again, you can just watch. I will do this slower later, but all of my 30s, because there's 30s, 60s, 90s, I got a deal. I've just done all the 45s. Okay, everyone got that? I did my 45s. Then everything else is over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over, oops, back that one up. Oh, okay, what was I there? 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So there's 12 pi over 6s. Now, do you see how some here, 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 and here, I go twice. Now remember, when I came all the way around, this is 12 pi over 6, right? Well, that's still 2 pi, right? Both of these are both 2 pi. So, whenever it is over 2, okay, I have two options. I can make it over 6, or I can make it over 4. But all the other ones will be over 3 or over 4. Okay? Now, honestly, that is how fast you can do a unit circle. You go like this, one, and then you do all your 4s, do all your 3s, and you're done. And then if you know one quadrant, you guys should remember that from last year. What was quadrant 1? It was 1, 0, then it was root 3 over 2, 1/2, root 2 over 2, root 2 over 2, right? And then it was 1/2, root 3 over 2, and then 0, 1. And then all the rest you can just reflect. Yep. Count by ones at every 30 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, pi over 3. Well, give me something over 3. 6 over 3 is 12 over 6. 12 pi over 6 is a 2 pi. Right? But that's not even on the unit circle, right? But give me something on the unit circle that's over 3. Pi over 3 is 2 pi over 6, right? 1, 2. Okay? So if it's over 3, I make it over 6. If it's over 2, I make it over 4 or 6. Doesn't matter. And all the rest are over 4, so they're really easy. Right? But you got to make sure you always count the 9, like the X and Y axis when you count around. Okay? So there is front loading to learn this. But I'll tell you, if you know your unit circle, you're going to find this so much easier. And I know that's what you guys want in the end, right? You should only by now, I am not a make work project kind of guy. I do not want you to do work that you do not need. Promise. Okay? So learn that unit circle and you'll see that these are not so bad. Now, 3 pi over 4, right? That's where theta is. It wants me, so this is how I would do that, you guys. this is what I would do. I would write this down and I would go 1, 2, 3. Okay, that's 3 pi over 4. What do you think this reference is right here? Not 45. Don't talk 45, so I don't want to hear that. It's like swearing now. What angle is that? Pi over 4, right? Because every one of those chunks is a pi over 4. That's pi over 4, that reference angle. Now, I know a lot of you guys are still hanging on to degrees, and it will make this more and more confusing as we go on. Okay? I showed you how to make a unit circle. Why don't you forget about degrees for a while? If that's 3 pi over 4, 4 pi over 4 gets me to the next one, so that must be another pi over 4, right? All my, what we used to call 45s are now pi over 4s, because 45 degrees equals pi over 4. What equals 30 degrees? Pi over 6. Okay, you know those two things, you can build yourself a unit circle, and then count by ones. And again, you go and you count by ones pretty fast, okay? But that's how I'm a trained professional. You guys work on it, okay? Okay? That's pretty quick, okay? I'll stop showing off and I'll get back to my job here. Now determine the reference angle for 4 pi over 3. What is that? What should I change it to? 8 pi over 6. Good. And this is how I would do that. Again, I'm going to show off a little bit here. 1, 2, 3, 4, 5, 6, 7, 8. That is 4 pi over 3. That makes sense? Okay, now, what would you say this reference is? How many pi over 3s is that? Oh, yeah. Oh, we should actually, well, how many pi over 6s actually, we should say? 2 pi over 6, right? There's 2 pi over 6s, which is pi over 3. At this stage, I will not go to the pi over 3 right away. I would lose half my class at this point. Okay? See, there's 2 pi over 6s there. Oh, that's pi over 3. Okay? Pi over 3, you're going to learn, is about 60 degrees, right? But you will, through redundancy, start to, I don't want you memorizing that stuff, but through redundancy, you'll just learn. Pi over 3s are 60. Okay? Pi over 6s are 30. Pi over 4s are 45s. Okay? How's that sound? It's a learning curve, obviously. Right? If it was easy, everyone would be taking this, right? Next thing, arc length. We're now going to find arc length. Now, this is what arc length is. Right there. There's my picture for you visual people in the room. And again, do your best. Now, how do you find arc length? Well, you need two things. You need, okay, like the radius, and you need this angle. If you give me the radius and that angle, I can tell you exactly what that length is. There's a catch, though. That angle must be in radians. Okay? And will they just ask you on the test, find the arc length? Absolutely. You will not fluke this one off if you haven't been to class. And I'll show you why. Okay? Now, the formula you will use, it's on your formula sheet, is arrow. Okay, that's how I remember it. A equals R theta, or A equals RO, right? Arrow. Get it? Okay? So A equals R theta. Very, very simple formula. Where is going to be the confusion? You will see. Okay. Let's just we'll do the next three. The pendulum swings at an arc of, through an arc of 45 centimeters. Through what angle does the pendulum swing? Answer in degrees and in radians. Okay? So, for you visual people, I will draw you a pendulum swinging. So there's the string, starts there, does this little path here. Actually, I can draw that solid. It has this little path, comes over here. It tells us that the length of that string is 30 centimeters. It tells us that it goes through an arc of 45 centimeters. It wants to know, what is that angle? Okay, on a scale of 1 to 10 in Math 30, this is a 1 difficulty. You wouldn't believe the amount of students students that probably get this one wrong, because they haven't been to class. Now, you guys don't understand this concept, but if you spent like a week in a big high school, right, you wouldn't believe how many kids just don't come. They register and they don't come, or they come every Monday or whatever. And it's quite frustrating, right? Because then they always come and they're like, well, I missed the last couple of weeks. What have we done? Help me out at noon, man? That'd be so awesome. And you're like, okay, yeah, that's about 18 hours of work I got to do in 1 noon hour. Now, what was the formula? A equals R theta, right? You take your arc length, which is 45. You divide by your radius, which is 30. That is your angle. 45 divided by 30 is 1.5 radians. Now, can you kind of picture where 1.5 would be? How do you convert that to degrees? Multiplied by 180 over pi. Because I need degrees on the top, don't I? So 1.5 times 180 divided by pi. What do I get? 85.9 degrees. Okay? And 1.5, we should be getting up to around the 90 territory, right? Because there's 1.5, 2, 3. Okay? 3.14 in the... Okay. Now, this is one that they will give you the formula. And it says calculate that. Now, I haven't been showing up for class. I'm good at this math, so I don't show up for class. Calculate the arc length of a sector of a circle with a diameter 9.2 centimeters and a sector angle of 150. This is exactly what. Now, students are like, radius, diameter. Yeah, you almost got me on that one. So they're like, okay, A equals, what would be the radius? 4.6, and they multiply by 150. Okay? That's what they do. And the answer they get is right there waiting for them. Okay? This is such a huge error. People just see that. Even you guys, I've told you, you can never put degrees in that formula. Okay? Remember we had this conversation. Right now, I'm going to say, remember I did that class. When you hand in your quiz, and you get that one wrong, I'm going to go, remember I know, I was rushed, I was thinking, right, everyone's got their excuses, and my, dog has fleas, and it's been just nuts in my house, so, Always remember to put radians in there, and then it's not so bad, okay? How do I put radians in there? I take 150 and I multiply by pi over 180, because the degrees will cancel. That's how I remember. And you actually get 5 pi over 6. And all I want to do right away is get that to a decimal, but never change anything to a decimal if you don't have to, because you're losing information. And you can get the wrong answer from that. Then it's as simple as 4.6 times 5 pi over 6. And how long is that string or sector of the circle? or no, how the arc length I'm looking for. How big is the arc length? 12.0 meters. Hopefully you get this one in the diploma. Not get it right. I know you're going to get it right, but it is one of those nice ones. There is 10 to 20% of that diploma is, have you been showing up for class? Right? There are some nice ones on there. There are little vacations as you're going through this, right? When you say find the radius of here's the arc length and here's, it's like, okay, good. Whew. I got this one, okay? And then, you know, maybe the second time through you're going to do it again, or you're going to draw your picture, see if it even makes sense, okay? Do something to be able to check it over. Don't take for granted that the easy ones you just got right for sure. Now this one here, we've got a circle with center C and a minor arc, okay? Here's your minor arc. The blue one, that's called your major arc, okay? Minor is the smaller arc, because they may ask you for the major arc, right? Which you could do if they give you the entire circumference. Just subtract minor or circumference minus minor arc, give you major arc. Now, it says that angle ABC and BAC is pi over 6. So I get pi over 6, and that's pi over 6. Give me my angles. So find the length of the radius. I am looking for R. Okay, and I have this formula. I know A. I don't know R. I'm looking for it. Can I find my angle? Yeah. What is a synonym to pi? 180 degrees, right? Actually, I should be very specific and put pi radians is. Now, pi equals 3.14. 1592. Pi radians is 180 degrees, right? Remember, 3 of them, and then that little chunk, okay? So with that knowledge, if I took pi, and there's a radian here, minus pi over 6 plus pi over 6. And again, those are radians there too. I would be able to find that central angle, right? Just like we've always done. All of the angles of a triangle always equaled 180. And if I knew 2 of them, I could subtract that and I could get that other one. Okay? So, to be able to do this, what would I change pi to so it has a nice number to subtract? Because if I can keep working down here, this is the same thing as pi radians minus 2 pi over 6, right? So how could I subtract? Yeah, what's a common denominator though? This would be 6 pi over 6 minus 2 pi over 6, which would be 4 pi over 6. Okay, even in your unit circle, 1, 2, 3, 4. Now 4 pi over 6 is not on your unit circle, but I guarantee 2 pi over 3 is. Okay? So 2 pi over 3 radians is my central angle, right? So now I'm able to do this, because that would be 2 pi over 3. Now, all you have to do is divide both sides by 2 pi over 3 radians, because they gave us this thing, nearest tenth. As soon as you see nearest tenth, it's like, awesome. Use my calculator. Okay, and again, where are you going to see this? This is a good numerical response on my exam as well as the diploma. Okay. What are we getting? Huh? That's what I'm getting. Seven point 7.26, right? 7.3 centimeters. I thought you said 7.6. That's what I was. Okay. 7.3 centimeters. So 1 to 6, ACE, and 7 to 17. Okay, now obviously you do not have to get this homework done tonight or whenever. What I do recommend though is that you try to get as much of your practice test done before Monday. So Monday is even a bit more relaxed for you, that all you're doing is you're answering those questions you still quite don't get, right? Instead of doing questions for the first time. Homework was 1 to 6 ACE and 7 to 17. This is the first homework. There will be a quiz on this, but not till first day after exam. So Wednesday. Thursday. So you guys are lucky that we actually have to do 2 when we come back, because the first class gets class on Wednesday. And I might get some notes with you guys on maybe get the quiz done. No. No, Thursday's not Easter. No. You gotta do it. No, I wouldn't do that. It's not fair. That's a backup. That's not supposed to be my chief. I've never wanted as that. It's fast though. Mm-hmm.